Hey guys, this is April 17th and this is Algebra for Faith. We're covering 9.5. Before we get into 9.5, just wanted to go over a little bit of housekeeping because this is Friday, April 17th. You should be working on two quizzes that were sent to you. The quiz on 9.1 and 9.2, which covers classifying and evaluating polynomials. 9.2 also covered adding and subtracting polynomials. Then I also sent you a quiz on 9.3 and 9.4, which was going over multiplying polynomials, and then yesterday's lesson, which was multiplying using FOIL. So that's what we've covered so far. Today's lesson's over 9.5. You will not receive a quiz for that until next week. And if you notice, there's only one more section, 9.6, which is dividing polynomials. And after you go over that lesson, you'll have a quiz on 9.5 and 9.6, and then you'll be ready for the chapter test for chapter 9. So I attempted this video just a minute ago, and it bogged down. So I don't know if there's something weird going on with my computer or what's going on, so we'll just have to see. Maybe I hit something. But just wanted to kind of let you know what's kind of going on, what you can expect. Remember, if you have a question, feel free to text me, call me. All your parents have that. That's the easiest way to get a hold of me because I just don't really check Facebook and YouTube messages. Most of my YouTube comments have been spam. Even YouTube is saying that, so that's probably not a good place to say stuff. But I will try to respond to you. I have answered some people's questions. I do not mind if you get together with other people and you try to figure out stuff. But remember, some of you are not taking advantage of the videos, and you should realize that some of the stuff you've done, you've never seen it before. You've never done FOIL before. If you did, you barely touched it in 8th grade. Today's lesson, you've not done it before. So you might want to just make sure you watch this before you ask a friend who may not have watched the videos either. You may want to actually watch the videos. That's why we're doing them. That's why they're there. So with that, let's take a quick word of praise and thanksgiving and supplication to the Lord, and then we will get started on our lesson. So Heavenly Father, you have given us just a beautiful morning this morning, right after I drove through mist from my valley and came up to the plateau to this beautiful sunshine, and I give you praise and honor and glory for your creation and for everything you do for us, especially that you sent your Son for our salvation. Father, help us to get through this lesson. I pray that the Holy Spirit will just reach out and touch understanding and wisdom for each child that's trying to get through this lesson. And Father, just be with our world. Grant wisdom to our authorities that are over us in both our country and our world. Be with those who are sick. Be with those who are lost and those who are just feel so hopeless and helpless during this time. We love you in Jesus' name. Amen. All right, guys, so yesterday we went over FOIL. Hopefully you've already got that in your brain, what FOIL stands for. It's a way to multiply binomials, not polynomials, simply binomials. Binomial meant there's two terms. So we are going over this kind of as a brief review of what we did yesterday, but also we're going to use the patterns we develop here to look at special patterns and special products that we're doing in today's lesson. And today's lesson, I don't know if you want to maybe put a little fold down a corner or do something like that, but this might be a chapter that you have to refer back to in chapter 10, because if you can learn the pattern right here, it's going to be really important when we start factoring in chapter 10. And I know factoring makes everybody almost panic. Don't worry about it. We'll get through it together. So let's look at what we're doing here. So I'm going to use first, outer, inner, last, and I'm going to multiply these two binomials. So my first two, x times x, is going to become x squared, because remember I have two little exponents of 1 that are being added together. My outer terms, that's going to become a plus xy. Inner terms is going to become a plus xy. And my last term will be a plus y squared. And what we notice when we multiply polynomials with FOIL is it ends up putting your like terms right in the middle where you can see them. So we're just going to go ahead and put those two terms together, and that's going to become 2xy, because remember there's like a little 1 in front of those xy's. So I'm just going to say, okay, I've got 2xy. So you can kind of notice what's happening here. Now, this looks exactly the same. These two polynomials look exactly the same, right? Or by the binomials, except one of those signs is negative. Wonder what's going to happen there. So x times x will be x squared. Outer, x times negative y will be a negative xy. Y times x will end up being a positive y. Right? Outer, inner, yeah. There we go. I'm just trying to look. I was like getting a little confusing. And then right here we have y times y. That'll be a negative y squared. So look what happens here. My two like terms are right in the middle. If I go ahead and subtract those, what happens? The xy's go away, right? They go away, and that pattern, or those two, multiplying those two polynomials, give me a pattern that looks like that right there. Now let's come on down here. Let's say, all right, easy breezy. I had some, that was just letters. Let's put some numbers in it, right? So let's put some numbers in it, and I've already completely messed that one up because I do not want to make it that difficult. Let's change that to a 5. That's what that one is supposed to look like. Because see, we've got two patterns here of just 5. Don't know why I put the 25 there because I was trying to multiply too quickly. So a times a will be a squared. Then I'll do the outer ones. That will be a negative 5a. Inner ones will be a positive 5a. And my last terms will be a negative 25. And you can see what happens. You got a negative 5a, adding a positive 5a. Those two just make a 0 and it goes away. And so what ends up happening, it's a squared minus 25 is your final answer. Now, here I have two binomials that look exactly the same, much like we had right here, right? Making sure you can see it. So we're going to go ahead and use FOIL. So a times a will be a squared. Outer will be a negative 5a. Inner, negative 5a. And my last term, negative 5 times negative 5 would make that a positive 25. And then those two terms I combine because that's a negative 5a, and then I'm going to add the opposite. I'm going to add a negative 5a, which would make that a 10a. So we're just going to go ahead and combine those. They're still going to remain negative. That will become a negative 10a. Then let's put some numbers with both of the variables and see what happens. Once again, this looks kind of like this one right here. See where we have a sum, and then we have a difference, and then we're combining them. So let's just use our outer or FOIL. We're going to start with the front terms. That will be a 4x squared. So you go ahead and multiply the 2 the regular way. 4. I'm going to multiply the x's. My little ones are going to go together and make a square. Then I'm going to do the outer terms. So 2x times 3x, those are positive. That will be a 6ax, or a 6ax is what that looks like, doesn't it? A 6ax. Then if I multiply the negative 3a to the positive 2x, that's going to become a negative 6ax. That looks good, doesn't it? Then finally, we're going to multiply the negative 3 to the positive 3. That's going to become a negative 9. And then the a's just combine together, and it's going to make it a squared. What happens to the axes we have in the middle? They go away to where I finally just have something that looks like this. So there's patterns that are starting to build. Remember, we got patterns in science. We've had patterns in math before. You all did 7th grade and 8th grade. You did all this sequencing stuff and all these orders and being able to develop geometric sequencing. What was the other one? The addition sequence. Oh, okay, it's gone on my brain, but you did all these. This is very similar. It's a pattern that we notice in math that can help us shorten things. So you can see already what's happening. All right, if I am multiplying polynomials that look the same, I get this pattern. Same. That's the same. Look, I'm getting a pattern. If I'm multiplying polynomials where the only difference is basically the sign, I've got, one is a sum, one is a difference, then look, they're right here. I end up with this, something that looks like this. And then finally, this was another one where there were differences. Well, guess what we're going to talk about today? This is two patterns, or two special products that we've got. I'm a 9.5. We're going to start with this one, because that's one that we did. Never know where to go on this, so hopefully this is not making you all seasick. It might make me seasick. So first of all, square the sum. Look what ends up happening. So you can see here that I multiplied the first ones, they become a squared. The second ones will become b squared. And then what happens in the middle is that you double the ab. Because look what happened. I'm trying to see if we've got we've got one over here. So you ended up having a 2ab in the middle. Well, look, we had one that was kind of similar to that right here in the middle. Yeah, right here at the top, we had the square of a sum. And we had that same pattern show up, where it basically, we combined those like terms, but it also doubled it, because we added those two together. Now let's go over here, because we have another pattern. So you have to be able to recognize this pattern for your quiz and a test. Just recognize if it's a square of the sum, square of the a difference, because that's our other pattern, is a square of the difference. So a square of a difference, the binomials are still the same. It's the same pattern. A minus B, A minus B. When I square them, look, it's very similar to what happens with the square of the sum, except since you have the difference, then the ones in the middle end up becoming negative. This one's positive, but that becomes a doubled AB. A negative doubled AB, or a negative 2AB, where over here, if it's the sum of the products, sum of square of the sum, then you ended up with a positive. So see those two patterns? And we had something that looked really similar to that. I'm going to take you on a ride again. We're going to go back all the way over here. We had something that looked really similar to that right here. We had A minus 5, A minus 5, and look what ended up happening. Basically, my inner and my outer terms ended up being kind of doubled. I was able to look at, and I'm just wanting you to start thinking. I can look at the inner, I can look at the outer, and I'm basically doubling that in the middle. That's kind of what that 2AB pattern is telling me. This is what's happening. Now, let's look at one that looks like this, where I have a plus and I have a minus, and those binomials are being multiplied together. We had one right here. I had a minus, I had a plus. Everything else was the same, but I multiplied those together. That is another pattern. Now, I'm on page 390. 390 explains square the difference, square the sum. If you want to read those, you can. Now I'm going to what's on page 391, and there's a handy-dandy little table that sums it all up for you. And if we look at what we're doing on lost it. When you have something that looks like these two little things, those two guys, I know I'm not on the screen, but I'll get there in a second. That's called a product of conjugates. The product of conjugates, that's on 391, so they're talking about that. So if we look at a product of conjugates, product of Conjugates. Let me make sure I'm writing this out. That's what these two patterns ended up being. But just let's look at what happens. Now consider the product of two binomials, one indicating a sum, one indicating a difference, okay? The sum of two terms and the difference of two terms. So if we stick with our A-B pattern, what if we had A plus B and the next one was an A minus B? We kind of had this right. We had it here, here. We also had it right here, guys, if you look at it. We also had one that looked just like this. And what ends up happening is the A squared. And then you're going to have a B squared. You're not going to have anything in the middle. Why? Well, remember what happened to each of the things right here? That middle term kind of went away because we had one term that was positive, one term that was negative, and they canceled out each other. Or basically they subtract out each other and they become a zero. So there's nothing in the middle. So that is three patterns that if you can look at it, they might help you figure out really quickly how to multiply those binomials. And we use that a lot in the next chapter. So let's go over it. Square the sum. A plus B, I end up with this pattern. A squared plus 2AB plus B squared. Square the sum. Square the difference. Isn't much difference. So A minus B, I end up with A squared minus 2AB plus B squared. Our other pattern that we had, and we did it 3 times in our lesson right here, in our lesson opener, was a product of conjugates. And if we look at what conjugates means, conjugates basically means these are two different things that I'm measuring to get, that I'm putting together. So two such binomials are called conjugates, and a product of conjugates ends up being the difference of the squares. So you know, if you have a pattern of binomials, we could put different numbers in here, which what we did right here. See, this one ended up being, I had different numbers, and I still ended up with this pattern. Even though I changed the letters, I changed the letters, I put numbers, but I still ended up with basically the difference of the squares of those two numbers. So that's our patterns. Let's go all the way down to page 391. On page 391, they have given you this table where I can just and this might be the one you want to kind of fold down a little bit. Maybe if you had a little Post-it note, you could put it right there, because right at the bottom, it has this little table that shows you everything that you need. So square the sum, it gives me this pattern. Square the difference, square the sum gives me that pattern, square the difference gives me that pattern, and then product of conjugates always gives me that pattern. And that's just a really quick pattern. Now, worst case scenario, if you say, I can't remember, I remember this pattern, what's the thing to do? Use FOIL and go ahead and do the multiplication. So it's not that big of a deal, all right? If you totally forget I don't know what to do. I remember there was something about a pattern, but I don't know what to do. Go all the way back to FOIL and just go ahead and multiply it. That's what we did on every single one of those. And that didn't take that long. But this is just a way that maybe you can recognize these a little quicker, especially when we get to factoring, okay? So factoring is almost like a division problem. So if you can see this pattern like this, you might start saying, that pattern has got these two things in it. I don't have to factor it because I know what the factors are. They're right there. See where we're doing this? A little bit ahead of time so we can start to build up to that. And your next section, 9.6, is division, which means that might help you to do a division problem of polynomials in the next section of this chapter. So let's move over to your homework. If you are traditionally doing this homework, my lesson says to do 1 through I wouldn't even do 37 ones. I would do like 1 through 35 odd. Once again, I'm not taking homework. I think you should do enough to be able to practice to where you can get it. Now, some of you I know, I just know, you're not looking at this until you actually pick up the quiz. And when you pick up the quiz, then you start trying to figure it out from the book. Some of you can do that, and it's probably perfectly okay. Some of you can't, guys. I mean, some of you, to be honest, all of you would probably do better, and you'd get it in your brain if you try to do the lesson day by day, try to practice it, and then if you're having trouble with the quiz or you go back to the video and do that. You have all those resources open to you. Remember, you can use it open book. So let's just do a few. This is basically a repeat of that pattern, just seeing if you can get this pattern in each one. So let's look at what we're doing. So on the first section, they're just asking you, can you just look at those patterns and go ahead and fill in the blanks? And so if you look, number 1 is the square of the sums. And they're just saying, square of the sums, what's going to go in the middle? They're just saying, can you recognize that pattern and fill in the blanks? Number 2 is the square of the difference. Can you recognize that pattern and go ahead and put in the operational symbols, which would be like a plus, a minus, and then a plus. That's what number 2 is doing. Number 3 is going to the square of the conjugates, not square of the conjugates, product of the conjugates rather. So, and once again, they're just saying, all right, you end up with an a square or b square, what's going to go in the middle? What's the operational symbol that you're going to put in there? And it would be a minus sign or negative, however you want to think about it. Then, when you go through the rest of them, if you notice what's happening, let's look at 7, and let's look at 9, and let's see if we can do those. So what I'm going to do is let's do 7. If I just look at 7, that's going to be a square of the differences. Let's go over here to my little section. Ooh, my cart's in the way. Other cart, not this cart. And let's look at square of the differences, because that's what number 7 is going to be. I just marked on myself too. 7. Square of the differences. If I have a 6x minus 12, and then I'm going to square it. That's what is happening, guys, okay? So technically that would be 6x minus 12 times 6x minus 12. Do you all see that? That's what that would be. But we're not going to use FOIL on this. We're going to look at this thing and say, all right, square the difference. It's going to be this pattern. So what's going to happen to that first term? And I can look up here. Well, x is going to be squared. But what's going to happen to that one too? It will be squared. So that's going to be a 36x squared. See how we're trying to get this a little bit in your brain? Now, let's think about what your outer and your inner terms would be. So the outer and the inner terms, and here I'm going to go, it might look a little bit, you probably can't see that, but I'm going to do this to where maybe we can look at it just a little bit. So that middle term is where I'm basically, it would be, I mean, if you can kind of see what's happening. The outer terms would be that times that, and then this times this, right? Well, technically what's happening is those two terms are being doubled. So if you think about it, you've got 6 times 12, right? So 6 times 12 would be, all right, see, this is where I really need you guys. So, because my mental arithmetic, yikes, I have been getting all kinds of text and I had not noticed. So, but that's okay. 6 times 12, okay, there we go, 72. So I've got 72. And so you could either do that and double it, or you could say, all right, I've got 72, and I have another 72, and I need to add those together. So that's going to become a negative, and you can look right here, that's going to have to be a negative 144. And then I'm going to have an x there, right? So x is there. So think about kind of what's happening. Those two terms combined, and these two terms combined, and it ends up being negative. So that becomes a negative 144x. Once again, if you're saying, this is not getting in my head, that's one reason why we're doing this, is to practice. Another thing, though, if you're like, this is never going to get in my head, relax. You can always use FOIL. It's not that big of a deal. Last term is I'm going to do square this one because B was squared. So that tells me I need to go ahead and I need to square the negative 12. So negative 12 times negative 12 is going to end up becoming a positive 144. Okay, so that's your answer for that one. I'm going to go to 9. 9 is going to be a square of sums. So if we go to 9, square of sums, it is a plus 3b, and that's squared. And I'm going to go ahead and we'll just write that out so you can kind of see what's happening to each one. The pattern should be that those inner terms should be doubled. So, which technically, I mean, that's kind of what that's telling you. So it's like basically these inner terms, that outer term is being added together. All right? So there's two of them and they're being added together, but for square of sum, square of difference, what's happening is those inner terms are being doubled. So this is where you start thinking, all right, I'm going to have AB, but basically what happens to my numeric value or my constant is that it's being doubled because of that. So the first term is going to be A squared. You can go ahead and if you wanted to see, all right, outer will be a 3AB, inner is going to be a 3AB, or basically AB is going to go together and my new number coefficients are going to be doubled, or it's going to be added together. That's going to be a 6. Or I could take one of the 3's and say, okay, I'm going to multiply that 2. So however you want to do it. Then my last one is I have to square both of those. So the 3 is going to be squared. That's a 9. The B will be squared. So that's what you have for number 9. Now, let's look for one that's a square of the conjugates. Not really saying, well, yeah, we could do 11, we could do 13. I was looking for some that has, let's do 13. If I can get this over here. And then we're going to go back and look at your last example. And your last example is what we do in like 16 and 20 and some of those. So, if we do, which one did I say I was doing 13? So if we do 13, we have a not negative, 5z minus 3, and then 5z plus 3. And we know that what's going to end up is we're going to have this pattern. So my first term is going to be squared, and my second term is going to be squared, and it's going to still remain a difference. Okay, it's still, my last term is going to be negative, or my last term is going to be subtracted, however you want to kind of think that through. So I'm going to go ahead and square my first term, and that would end up being a 25z squared. This pattern is telling me, don't worry about outer, don't worry about the inner, because it's going to be canceled out because this is product of conjugates. They will cancel each other out, or you're going to put them together and you're going to end up with a 0. So don't worry about that. Just go ahead and square your last term, and that's going to end up being negative 9. And so then you're done. So most people, what I found in my experience with algebra and math kids is this one they use quite a bit. This one is, the square of the sum, the square of the difference. It's a little shaky for them. And then they get a little bit better once we start trying to factor. So we've done a little bit of our homework. Let's go ahead and look up there on page 392, because that's where we were working with your homework. And up at the top, those patterns that we've talked today, square of the sum, square of the difference, product of conjugates, can actually be used so you can really quickly get through and complete some products and to get some numerical patterns. Now this isn't really tested or quizzed, but it's just something, it might be beneficial to you, especially in standardized tests, guys, because you lose a lot of time trying, we can't use this, but if you got a calculator, you lose a lot of time when you start trying to punch in stuff. So if you can get this down, then perhaps it can help you really quickly. So, and then, maybe not. But anyway, if you want to look at like what your special product pattern is on example 6, that's what we're doing in 16 and 20 is where, actually it's 16 through 19 is what we're doing. I'm going to do one of those, but like I said, if you're thinking, this is crazy, and why am I doing this? This is not quizzed. This is not tested. I just want you to make sure that you know how to do it so you can do your homework, okay? So if we look at what was happening with computing, what we're going to do is we're going to take those and make them into conjugate patterns, into a conjugate pattern. So we have 16, this is, hold on, yeah, I'm doing number 16. And we have 15 times 25. And we're going to try to look at the product of conjugates and see if we can write up a pattern with that. So I know this is kind of confusing, but that's what the next chapter is. It's you trying to learn how to do things backwards. Just like multiplication is doing it one way, division is doing it the opposite way. Well, this, when you get into factoring, sometimes that's what your brain has to do. You kind of have to think, okay, what in the world am I doing and how can I get that? This is just giving you a foretaste of kind of factoring. So if I was going to try to express this in a product fashion, then what they want to do is, what could I come up where I would end up with something like this, where I ended up with that, and where I ended up with that. And this one seems to come out really, really clearly. Okay, that's a clear square. That's not going to be that big of a deal. This one is where I think you're going to have the issue. But what you might want to do is, okay, 15 times 25, what does that come out to? Now, what they're saying is, all right, maybe you can come up with that really quickly if you were able to come up with a conjugate pattern to simplify that. So this is how they set it up. So I know my last one is going to be a 5, right? And I'm doing a conjugate pattern. Then what you're trying to figure out here for the first one is, all right, what would be something I could square, and then I would be subtracting 25 to where I would end up with what the product of this whole thing is. Well, basically, what you would come up really, really quickly is if I squared 800. So, sorry, not 800, 400. If I squared 400 and then subtracted 25, that's what I would end up right here. So that would be like 20 times 20. Once, and one of these needs, that needs to be less. So, like I said, this is not tested or quizzed at all, so don't worry about this too much. This is just trying to tease your brain, just saying, okay, can you get to these higher product powers, and can you do this? Now, if you'll look on your example 7, where you're expanding it and being able to use distributive property, there is one that's on, I think it's a test or a quiz, that kind of looks like this a little bit. Once again, you don't have to use the patterns. To me, rather than trying to use all the patterns and use this stuff, it's a little bit easier just to go ahead and multiply it the regular way. So that's, don't get too stressed out if you're like, I cannot figure out example 6, I cannot figure out number 7. Well, that's just, do regular multiplication. It's not that big of a deal. All right, so that's gotten us through special products. Tomorrow we do division. Historically, most people are a little shakier on division than they are on products or multiplying. So we'll try it. Tomorrow's lesson might be a little longer as we get through that. So the main focus of this lesson is that you learn those 3 patterns, which is product of conjugates, square of sum, and over there, square of difference. It's trying to learn those patterns and keep those in your head, because especially in the next chapter, you're going to use those or be able to use that pattern to help you factor a little bit. So, excuse me. So that's the end of today's lesson for April 17th. So I'm doing it for where this would be your last lesson before you go on the weekend. So guys, have a great weekend. Hopefully you can relax and maybe not do so much school stuff. Or if you're doing this on another day, then relax and have a nice evening with your family. So we miss you guys. We pray for you daily, and please stay well, and please continue to keep everyone in prayer during this really weird time. All right, so love you guys. See ya.